Welcome to the ultimate guide to mastering DevOps in 2025. DevOps is one of the largest growing IT professions, and because of AI threatening to replace many roles like test engineers, database administrators, data analysts, and so on, DevOps is becoming the future-proof alternative for all those engineering roles. So if you have already recognized the importance of DevOps for your future engineering career, but are absolutely overwhelmed and unsure where to start, here is the clearest, most straightforward learning path for you to learn DevOps. Now, no matter how complex something is, even if it's rocket science, you can always break it down into manageable, simpler pieces. So instead of giving you this huge list and guide of learning DevOps, where by the end you're already overthinking whether you really want to pursue DevOps or not, I wanted to make it simplified and manageable. So I broke the whole thing down into 4 stages or layers that each lead up to the next one. And you will find this whole roadmap as a PDF below to serve as your guide in your DevOps journey. Now, picture this: a symphony orchestra where you have various instruments like various DevOps tools that each play a critical role. And you have the conductor who brings it all together. And that conductor is the CI/CD pipeline, which I also call the backbone of DevOps, orchestrating a harmonious flow of code, builds, tests, and deployments. So I want to explain to you all of DevOps with this analogy, where at the end of the video, you will understand that streamlined pipeline with all these DevOps tools is the symphony of music the orchestra produces. And yes, that's how much I love these things, that I'm literally comparing an end-to-end CI/CD pipeline to a beautiful symphony of orchestra. So let's walk you through the DevOps roadmap divided into 4 phases to help you become the maestro of this orchestra. And here is an important part. This is exactly the order in which you should learn these things, to make your learning as smooth as possible. Because when you learn a new concept, usually you need to know some other underlying concepts before that. So knowing what to learn, when, and in which order will not only make your learning smoother, because you will be building your knowledge in layers, but also reduce the time you need to learn tremendously, because you won't need to go back and forth getting stuck because you missed an important part before. And this is exactly how we structured our DevOps Bootcamp, to literally take you by hand and walk you from start to finish, step by step, without any detour. And of course, everything that I mentioned here, you learn in detail and in depth in the DevOps Bootcamp. Before we dive into the roadmap, it's important to understand that DevOps engineering is not an entry-level engineering role. Instead, it's a highly valuable skill set that professionals in various IT roles, such as software developers looking to stand out or system administrators aiming to stay relevant, build on top of their existing expertise. So let's start with stage 1, which is prerequisite knowledge of DevOps. So these are the things that you need to build before you even start with DevOps specific technologies and concepts. And with orchestra analogy, first, we need to tune our instruments. So let's start with getting the basics right before we can even start. First, we have operating systems like Linux as the common stage for our orchestra. Almost every tool in DevOps runs on Linux. So you need to learn how to navigate shell or manage processes and understand file permissions and so on. So knowledge of Linux and Linux commands and scripting is foundational but very powerful part of DevOps skill set. Operating systems are basically foundation of computing environments. Whether you want to run pipelines or spin up servers for Kubernetes, it's all powered by Linux. Most Docker containers use Linux images. And as a DevOps engineer, you will work most of the time with remote servers on cloud, which use Linux operating system. So this skill is as essential as, like having a stage and a solid floor for the concert to even take place on. Next up, we have Git, which you can think of like music sheets for the orchestra. to make sure everyone plays from the common music sheets and things are documented transparently. Music changes are made on the sheets first before they are played. So Git is like the sheet music. It tracks changes and ensures that everybody in the team is playing the same tune. So with Git, you would need to learn about branching strategies like Git flow and trunk-based development and tools like GitHub and GitLab and so on. And it's very important to understand that in DevOps, we have this common concept that we call everything as code, or X as code. That includes other underlying concepts like infrastructure as code, configuration as code, and so on. So this is like an umbrella term. And Git actually plays a central part in all of these concepts. It means we code a lot of the configuration that previously were done manually on local computers of some engineers. So we code configuration, we code infrastructure creation, we code the pipeline logic, we code every type of automation logic in our systems, and so on. And that code will live in a repository which all the team members can access, and using various Git features can collaborate on that code. Like, creating merge requests, resolving conflicts, creating branches, using various Git workflows, and so on. So you need to learn those Git features that let teams collaborate on code changes efficiently. So this is another skill that you need across multiple tools and DevOps concepts, whether you are writing a pipeline or infrastructure configuration or Kubernetes manifest files or application code or whatever. Next up, we have build and package management tools. Now, whenever you're developing an application, you have an application code, but we use a bunch of libraries and modules, basically code that other people have developed and are hosted on internet within our application. These libraries have versions and release cycles, bugs get discovered in them or new features get added. So you need to upgrade them to use the new versions of those libraries or dependencies for your application. So for managing this list of dependencies for applications, we have the dependency management, or also called package management tools. And there are different tools for different programming languages. Like we have NPM Package Manager for JavaScript, we have Gradle and Maven for Java applications, and so on. Similarly, music publishers distribute the right versions of sheet music to ensure musicians have the most up-to-date music notes in front of them. So the last toolset of DevOps essentials or prerequisites is the application dependency management or packaging tools. As I said, these tools resolve dependencies, handle any compatibility issues between those dependencies, but also allow to run automation tests on your application code and so on. So these package manager or packaging tools, basically we're creating jar files from Java applications or zip files from JavaScript applications and so on. But now that we package everything as Docker images, those tools are not needed for that specific use case. And we're going to come to the package repositories or artifact repositories to understand how that affected the distribution of application packages. And that leads us to the stage 2 of DevOps, which is DevOps fundamentals. And first, we have containerization with a specific most popular container tool, Docker. Now, again, back to our analogy, the music instruments need a case to be safely transported to the concert venue, right? Imagine if you just threw them all inside a car without a case. Not only they may get damaged, but it would be hard to untangle them from each other once you unload them from the car. Also, think about this. Some instruments actually have additional parts, or maybe some replaceable pieces that the player can actually mount on the instrument itself. So with the case, you can actually pack everything that the instrument needs inside the case. So container technology like Docker is the instrument case that ensures that every musician's instrument is safely packaged, easy to transport, and with all the needed parts packaged inside, ready to play upon arrival. The same way, Docker containers encapsulate an application and its dependencies and everything that the application needs to run ensuring its consistency no matter where the application gets deployed. So learning Docker is an absolute essential skill of a DevOps engineer. Next up, we have what's called an artifact repository. Now, those instruments need to be stored somewhere safely, right? So we can grab them anytime we need. They need to be, maybe temperature controlled, in a locked room that someone doesn't steal them, and also organized in a nice way so that we can grab them easily whenever we need to use them. So that's where artifact repositories or artifact registry comes in. So artifact registry is like a storage for all the different types of instruments. And as I said before, Docker, we had instruments stored without cases in the storage rooms, like having jar files and WAR files and zip files built with those packaging tools, just lying around without this common packaging or cases. And registries like Nexus, for example, supported storing different types of artifacts or instruments. So no matter which programming language you use to write an application, you can store the artifact of that specific tech stack in Nexus because it supports different types of artifacts. And also very important to note the difference between registry and repository. Registry is like a storage building or a whole section for storing the artifacts. And repositories are like individual storage rooms inside, and each room has one specific type of instruments stored in it. So you had one room that stored only violins, let's say you had another room that stored only saxophones, and so on. So a repository is one specific room that stores one specific type of instrument, while a registry is the entire building with all these different rooms. And with Docker, as I said, the change was that those instruments are now stored with their cases instead of just sitting there without the casing. And Nexus itself has a Docker repository type as well. But as you probably have learned with Docker, we actually have specific Docker registries for storing only Docker images, where you have rooms for each instrument, so Docker repositories within that registry, but the instruments are stored with their corresponding cases. And when we want to deploy containers, we can grab the image from that Docker repository. Now, the next one is Cloud Basics. Now, for the concert to even take place, we need an actual concert hall or building where the concert will take place. So that is a cloud infrastructure. All the servers that need to run these systems. So think of the cloud platform as the concert hall or the venue where the orchestra is playing, the audience is sitting, all the lights and electricity, the heating, and so on, that make up that building. So cloud platforms provide the underlying infrastructure, the servers that are connected with networking configuration to power and run all those services and applications. So you need to learn how this infrastructure is set up, all the servers and the storage and the networking basics to connect those things together to understand how all this underlying infrastructure actually works. Now that we have all the instruments in place and packaged and stored safely and even being transported safely, now it's time to get everyone in their place, let people in, and set the stage. So this is stage 3 of DevOps, which I call DevOps Core. And the first tool in this stage is Kubernetes. So think of Kubernetes as an orchestra manager who prepares the stage, who lets people in, brings in the players on stage, and so on. Those instruments that are in boxes or containers need to be unpacked and deployed, placed on stage to be played, right? So Kubernetes assigns the seats, distributes the music sheets, and ensures that every musician is present and ready to perform. It takes the containers or the instruments from the cases and arranges them into a cohesive group, managing their placement, load balancing, and scaling, and so on. And if one violinist, for example, suddenly cannot play anymore, Kubernetes will quickly find a backup or adjust the arrangement to compensate for that loss. So in the same way, Kubernetes is this powerful technology that runs all the services smoothly making sure all the operations is actually done seamlessly. So here is an easy explanation of Kubernetes for you in just a few sentences. Imagine taking hundreds or thousands of Linux servers on cloud and putting a layer on top of that, an abstraction layer, which is Kubernetes, that turns these machines into one giant, powerful machine. And thousands or tens of thousands of services and applications can run on this one giant machine and talk to each other and connect with each other as if they were really on the same machine. So Kubernetes basically takes care of networking between these thousands or hundreds of servers to make sure that we can deploy all these applications and services on top of that in an easy way. But that's not all. Once the applications and services packaged in containers get deployed on Kubernetes, Kubernetes also becomes your operations engineer that works 24/7 for you. So if any service dies or has any issues, it basically just goes and restarts them automatically, which is this famous self-healing feature of Kubernetes. Kubernetes also allows you to run multiple clones of each application with deployment components. So when you add a new replica, it basically automatically reconfigures everything on the fly, like updating the service and load balancing to this additional replica of the application to route some traffic to that new instance. Now, it was obviously clear that I would spend most time talking about Kubernetes again because I love Kubernetes and I could talk about it for hours, but let's move on to the next important concept in the DevOps core phase, which is advanced cloud platform skills, and specifically with one of the largest public cloud providers such as AWS. Now, let's say your orchestra is so popular that more and more people want to hear you play, so you suddenly need a larger venue or larger cloud infrastructure to accommodate for that. And obviously, the larger the venue, the more complex it becomes to manage, right? Larger venues have more features, they have higher security demands and measures, they have more sections, more complex infrastructure requirements, and so on. You also have bigger stage, so maybe you need more players and more instruments. So as a DevOps engineer, you will need to learn how to manage all this complex infrastructure and how to scale infrastructure and use Kubernetes, your general manager, to fill the stage, allow more people to come in as an audience. So if that smaller concert hall was a simple cloud platform like DigitalOcean, for example, now we move to more complex cloud giants like AWS or Azure or GCP, where the services are more powerful and flexible, but also more difficult. So you go from easy, high level to complex, low level infrastructure configuration. So Kubernetes will also use the venue, the cloud environment, for more advanced use cases, using various features that the venue offers to run everything smoothly and efficiently. And as DevOps engineer, you will need to learn one of these cloud platforms. AWS is the largest one. That's why I always recommend to learn AWS first, because the good news for you is the concepts are very much transferable from one large cloud platform to another. And as cloud platforms provide hundreds of services, obviously you need to learn the foundational set of services specifically as a DevOps engineer. And some of those services are networking and compute services, storage configuration, as well as general account security management services for access permissions and so on. Now, those large cloud platforms actually have own services for everything. For example, imagine if that larger venue had their own storage rooms for the instruments or containers. The same way, AWS actually has its own Docker registry called ECR, where you can store the Docker images. So the larger the cloud platform, the more services they usually provide in-house. So you don't have to use those external third-party tools, but you can basically do all the things in that cloud itself, which has a disadvantage to be locked into that cloud platform. So people still prefer to use independent, open source, third-party services, but they do provide those services for convenience to use on the cloud platform itself. So imagine if the venue had their own manager for the entire concert. Remember, the main manager that basically runs everything and oversees everything is Kubernetes. So instead of the orchestra hiring the manager, imagine they used the experience manager that the concert hall itself provided. And this would have a lot of advantages because, again, let's say they have an experience manager. Also, the manager knows better than you how the venue is actually set up and how it works. So they can run these things without you, like managing the building and tickets and all the infrastructure. But you still need to train them on your orchestra specific needs, like managing your players or distributing the sheets or instruments, making sure that it all runs smoothly. Well, that is an analogy for managed Kubernetes cluster on cloud platforms such as EKS on AWS. So the cloud provider manages a lot of the work and administration of Kubernetes for you, especially the parts related to the cloud resources themselves, and they do it better often than you. So you can just focus on running your services and applications, or in this case, on the orchestra part instead of all the work around the concert organization. And because Kubernetes is so complex, a lot of companies, a lot of the projects actually prefer to use a cloud-managed Kubernetes cluster because it reduces the complexity of managing Kubernetes cluster yourself, which is a very challenging work. So that complexity and effort is reduced tremendously. And that's why services like EKS is actually widely used, and a lot of DevOps engineers are expected to learn and know how to run and use those services. Because even if managed Kubernetes clusters are easier to run, they're still complex to use and manage because there's still a lot of work that remains on your side. That's how complex Kubernetes is. Now, it's time to actually play the music. We have prepared everything all around it, but now it's time to play. So we have the whole orchestra set up. Everything is organized. Players or musicians are on stage, but there is the most important thing or element missing here, which is the conductor. You know, the guy waving the wand. So bring in the conductor, the CI/CD pipeline. And this is literally where magic happens. Why is it important? Because the conductor, orchestra, sets the direction, sets the pace. They give cues to when to start playing, in which order. So that's the CI/CD platform, the orchestrator of all things. Conductor who leads the entire performance, ensuring all musicians, tools, and processes are in sync, playing their parts flawlessly and maintaining the rhythm of the piece. The conductor is at the heart of the orchestra itself. The conductor is basically the element that brings together all the musicians, ensuring that everyone plays in harmony, keeps up with the pace, transitions smoothly from one movement to the next. And the same way CI/CD pipelines actually coordinate the workflow of building, testing, deploying, monitoring applications. And that's why CI/CD tools like Jenkins, GitHub Actions, GitLab CI, and so on integrate with every single one of these tools that I mentioned, because it needs to talk to each of the tools to execute them, to tell them what to do when, in which order, when to build Docker image, when to push it to the repository, when to deploy it to Kubernetes cluster. So learning CI/CD platforms as DevOps engineer is the absolute core skill set. But you also need to understand all the other tools first, because you will be automating workflows and tasks of those tools with the CI/CD technology. And that's why DevOps engineers need to know such wide variety of tools, because they literally have to take them and integrate them with each other to build these complete full DevOps processes. And finally, we get to stage 4 of DevOps, which I call DevOps Advanced. So we mastered the core of DevOps, which means we already are able to build complete and end-to-end DevOps automation processes. Now it's time to take it a level up to the absolute mastery level of DevOps. And as I said, here you become the maestro, mastering the tools that make the orchestra truly world-class. First, we have infrastructure as code. And these are the tools such as Terraform or Pulumi that give you this power in your hands to automate almost everything, to build up the entire cloud infrastructure in Kubernetes on top of it from scratch using automation scripts. So think of infrastructure as code tools like Composer of music. So Terraform and Pulumi can be used by teams to manage resources across multiple clouds, to track any changes, to maintain consistency, and as I said, build everything from scratch with a really high level of complexity. Now, before moving on, I actually want to give a shout out to Pulumi and thank them for sponsoring this video. Pulumi is actually a game changer for those working with infrastructure as code. Because unlike tools like Terraform that use their own domain-specific languages, Pulumi lets you use the programming language that you already know and use extensively, like Python, JavaScript, TypeScript, Golang, whatever you are already using in your tech stack. And this means you can use your favorite code editor and your favorite tech stack to write infrastructure as code, leveraging all the great features like error checking, autocomplete, refactoring, and debugging tools that you're already comfortable with and familiar with. So a huge benefit of Pulumi is its flexibility. Pulumi integrates very easily with CI/CD pipelines and works with all major cloud providers. And essentially, it's a great tool for both developers and operations teams. Now, since we're moving into an AI-driven world, Pulumi's latest feature, Pulumi Copilot, can actually help you generate infrastructure code by simply describing what you need in natural language, but it goes beyond that. By asking questions, you can actually get deeper understanding of your team's specific cloud usage and valuable insights of your infrastructure. For example, you can ask Pulumi Copilot whether you have any unused AWS resources, and you can immediately reduce your AWS costs by simply removing those unused, unnecessary services. Pulumi is open source, so you can use it for free, but if your team wants to unlock enterprise features, including Pulumi Cloud with its automation API, policy as code, and the popular Pulumi deployments feature, you can use my code, Nana500, and you will get $500 worth of credits for the enterprise version. I will leave the link in the video description, of course. And now let's get back to the next skill in the DevOps roadmap, which is yet another automation tool and a programming language, Python. And while Terraform or Pulumi are composers of the music that orchestra plays, think of Python as your versatile assistant. It's like your runner assistant. So Python can be used to basically automate any type of small, repetitive task that you can imagine on a very flexible level. You can write scripts to interact with APIs. You can write scripts to monitor different tasks. You can write scheduled scripts and so on. And as a DevOps engineer, learning a programming language such as Python is a huge advantage. Because in DevOps, everything is literally about automating and making things efficient. You will often need to automate tasks and integrate systems and troubleshoot complex issues. So Python can be that glue that basically lets you integrate different systems, or it could be just a simple tool that you can delegate some repetitive manual tasks that need to be run consistently on multiple systems maybe. And Python is one of the best choices in automation scripting because it's very easy to understand, especially for engineers coming from non-developer background like system administrators, network engineers, and so on. They can easily learn Python. It's flexible, and more importantly, it has a very large ecosystem of libraries specifically for automation use cases. Then we have yet another popular automation tool, Ansible. With Ansible, you can actually think of it as section leaders to each group of musicians in your orchestra that basically ensure consistent guidelines within that group of players and make sure that all musicians within their section are in sync, playing their parts correctly all the time, and adhering to the overall vision of the conductor. So the responsibility of Ansible, in this case, is to coordinate repetitive tasks which are very critical for the overall configuration of the systems, like tuning instruments before a performance so everyone is prepared and aligned. And Ansible specifically is a tool that helps you manage hundreds or thousands of servers in a consistent manner, keeping the operating system packages up to date on all those servers, patching those servers, and so on. So combination of these automation tools, such as infrastructure as code tools and configuration tools like Ansible, with an addition of Python for edit flexibility, will basically help you create systems that even if you replaced musicians, or even if you changed venue, everything will still run consistently with no hiccups. Everyone will still know what to do and how to do it. So this infrastructure and configuration automation is like your well-defined processes and systems. So using these tools, you can basically replicate the same experience and music with any players on any venue. And the same way, for example, if your entire infrastructure goes down and you lose all the servers and your Kubernetes cluster crashes and you cannot recover that old running system because you have scripted everything from scratch, you can use the same script to recreate exact same replica of the system within minutes, because all the logic and all the configuration is directly baked into those Terraform, Pulumi, Ansible, and Python scripts. And that's how powerful automation is, especially in complex environments where you have thousands of servers. Because imagine manually creating and configuring and updating and keeping track of such a huge and complex infrastructure. That's why knowing these tools is absolutely essential, especially if you join a company that has complex infrastructure. So these skills will make you an extremely valuable engineer. Now, we're not fully done here because we want to achieve complete mastery. We don't want to just be average. And that's where the final piece of the automation toolset comes in DevOps advanced stage, which is monitoring and observability. And specifically with one example of a popular observability tool is Prometheus, especially in a Kubernetes world. Think about Prometheus as the audience listening carefully to the orchestra's performance, basically having the real life experience of how things are going, identifying immediately when something feels a little bit off, like the player is out of sync or a note is missed. They analyze the performance and provide detailed feedback to ensure continuous improvement of the performance. So Prometheus, or observability tools in general, they capture real-time metrics from the systems, the infrastructure, applications, the Kubernetes platform itself. So basically all the moving parts of the system, notices any spikes in usage, any downtime, and so on, much like an audience would detect errors in a performance. So these are the 4 stages or 4 parts of learning DevOps that each represent a layer of DevOps knowledge that you can build on top of. Now, there is one important element that is, it's not really a tool or a concept that you can learn in isolation, but rather something that is ingrained or should be ingrained throughout the entire process of DevOps and as part of each and every single technology that we discussed. And that is security. And security is especially important skill set from a perspective of a company or an employer. And security is an extremely important, but often kind of overlooked skill set. But it needs to be taken very seriously. Imagine with our analogy, someone changed the notes of the bass players, for example. They will be completely off tune and ruin the concert. Or let's say someone impersonated the conductor. You know, the guy who controls who does what in which order. So they can take over and do evil stuff and completely ruin the music. Or let's say someone broke into the instrument storage and broke the instruments and damaged the entire room, or manipulated secretly one of the instruments. So for every part of the process, we need to have security measures in place, like the guards at the entrance that validate the entrance tickets to the concert, making sure that nobody comes in that disrupts the concert, making sure the storage rooms are locked and only authorized people have access to them, making sure that no one can impersonate the conductor. So security is kind of this hidden thing that should exist everywhere, and you only notice its absence if something bad happens. So security, as I said, is extremely important, especially in DevOps, where so many different technologies are integrated with each other, where every single integration actually exposes an attack surface. So that means while learning each and every one of those tools, you need to learn them with the security best practices as well. And as I mentioned at the beginning, you learn every single one of those tools in exactly this order in depth in the DevOps Bootcamp. And if you check the DevOps job descriptions, no matter in which country or which company, you will see that this is a pretty complete list of what an experienced DevOps engineer is actually expected to know and what we teach proficiently in our DevOps Bootcamp. Which means we take even beginners of DevOps, but we don't just prepare you with some entry-level DevOps knowledge, just enough to get you an interview or just enough to get your foot into a DevOps job, because that's not a goal to strive for. That's a very low aim. Instead, we prepare you to crush any DevOps interview, to stun your interviewers, making them question, how come you know all this stuff, even though you don't have any DevOps work experience, and perform confidently in your DevOps job after you actually get hired. So that's the level that we're aiming for, and that's what we prepare you for with our DevOps Bootcamp. Now, I hope this video gave you some guidance in your journey of learning DevOps. If it did, please let me know in the comments. What was the most interesting or most helpful part of this roadmap? And don't forget to grab your learning path as well to help you in your DevOps journey. And with that, thanks for your time and see you in the next video.